Hey all, welcome to a new video of Maths and NIOS in the secondary course. Today we are going to do Check Your Progress 2.1 from the chapter Relation and Functions. Before going to the video, I would like you to subscribe to the channel, give it a thumbs up if you like the video and share it with your friends. Okay, let's begin. The first question is, given that A is equal to 4, 5, 6, 7, that set is A, B is a set with the elements as 8 and 9 and C is only 10, and you have to verify that A cross B minus C will give you A cross B minus A cross C. So this we have to verify in our question. We have to take the left hand side LHS, that is A cross B minus C. That means you have to find A cross B minus C first. So when you find B minus C, you will be having the result as 8, 9 as a set. Okay. So you don't have anything to reduce from here. So the result is 8, 9. Now you have got 4, 5, 6 and 7 in the first set, that is A, and then 8, 9. Find out their Cartesian product. So when you find Cartesian product, you will be getting 4, 8, 4, 9. Then comes 5, 8, 5, 9. See, this goes like this, 4, 9. With 8 and with 9, 5, 8 and 9, 6, 8 and 9, that combination, and then 7, 8, 7, 9. So you have got these many elements in your result. Okay, no need to put it as a set. You have this as the result. Now let's check what is there on the right hand side. So right hand side has A cross B minus A cross C. So let's check what is this A cross B. So A cross B, you have to have these elements, that is the same thing that we just did. 4, 8, 4, 8, 4, 9, 5, 8, 5, 9. These are the product of A cross B. Now let's do A cross C. So in that case, you will be having 4 cross 10, 5 cross 10, sorry, A 4, 4, 10, 5, 10, then 6, 10, and then 7, 10. Here, you have to reduce from this ordered pair, this pair. So you will not have anything to reduce from here. So you will be getting the final result as this one, A cross B. That means 4, 8, 4, 9, 5, 8, 5, 9, 6, 8, 6, 9, 7, 8, and 7, 9. This is the final result that you are going to get, which is exactly same as your left hand side. Hence, left hand side and right hand side both are same. So your statement is verified. Okay. So just you have to keep in mind what is the Cartesian product and how to find it, and you also know how to do the difference of two sets. Okay, these two things you have to keep in mind. Let's go to the next question. Second question is, if U is a universal set and A and B are its subsets, okay, where U is equal to these elements are there, A is equal to 1, 2, 3, 5 and B is a prime number. Okay, so you know that you have to convert it into roster form of B. So you know already universal set has 1, 2, 3, 4, 5. So it will not go beyond this number. So B has elements as prime numbers. So out of this, which are the prime numbers? 2, 3 and 5. So these are your elements in B. And A set has 1, 3, 5 as the element. Now find A complement cross B complement. So let's find first what is A complement and what is B complement. So from the universal set, you have to remove these elements and write rest of the elements, that is 2 and 4. So A cross has 2 and 4 as the result, and B cross has 1 and 4 as the result. Okay. So these are the result of A complement and B complement. Now we have to find A cross A complement cross B complement. That is, find out the answer, that is 2 1 2 4 is one pair, two pairs, and then 4 1 and 4 4. This is the final result. Okay, so the final result will have these elements. Final result of your second question. Let's go to the third question. Third question says, if A is equal to 4, 6, 8 and 10, these are the elements of your set A, then B has 2, 3, 4 and 5. And R is a relation defined from A to B, where the relation is A and A belongs to this set A and B belongs to this set B. And A is a multiple of B. That means this element's multiple should be here. When you define the relation, that pair should be as the result. So your relation should come as, for 2, 4, 6, 8 and 10, all are its multiples. So 4 2, 6 2, 8 2 and 10 2. So you can have all these elements. Then comes 3. For 3 only you will have 6. Okay, no other numbers are there as multiple of 3. So 3 1s are 3, 3 2s are 6. Okay, then comes 3 3s are 9. So you are having only 6 as the result. Then comes 4. For 4, again say the table of 4, multiplication table of 4, that is 4 1s are 4. So you will have 4 comma 4. Then 8 comma 4, only these two elements. Then comes your 5. For 5 only 10 is available. So this is the set defined where A comma B is the result. That is why we are writing this 10 as first. Okay, so this is the final result of your relation. Now the question that is being asked is, so R in the roster form you have to write. That is, if you write in the roster form, this is the result of your relation. Okay, the next one is domain of R. So domain of R means you have in the first pair, in the pair the first element will be the domain. So 4 6 8 and 10, again these are repetition, so you have to write domain as 4 6 8 and 10 only. This is domain. Okay, next one is range. Range of your relation is the second element, that is 2 3, this 2. Okay, this is repetition, 3 4 and 5. 2 3 4 and 5 are the result of range. So this is how we have to find out domain, range, and already relation is mentioned according to the condition. Hope you understood this question. Let's move on to the next question. Next question is fourth one. If R be a relation from n to n, that is natural number to natural number, defined by this, okay, x comma y, where this is the condition mentioned and x and y belongs to natural number, you have to find R in roster form, domain and range. So first you have to find the relation that exists between this condition. Okay, 4x plus y is equal to 12. So it's a natural number starting with, the relation is given as 4x plus y gives you 12. Okay, so x and y belongs to natural number. In this case, natural number you can write it as starting with 1, then comes 2 3 4 and it goes on. It's not mentioned anywhere what is the final number, but the condition this has to be satisfied. Okay, so let's check with the first, that is 1. So consider x is equal to 1. So y we have to get in that way, 4x plus y is equal to 12 replaced with 1. In that case it becomes 5, and then it becomes 4, and then you have to replace the y with 8. 4 plus 8 will give you 12. Okay, In that case, the first order pair will be 1 and 8. Then check with 2. Now replace this x with 2. So 4 into 2 will be 8. And 8 plus this y should be 4 this time. 2 comma 4. So value of x is 2 and y value is 4. That will give you the result as 12. So this is second order pair. Now next number you can check with 3, that is 4 into 3 plus 4 3s are 12, and here it will be 0. So that need not be mentioned because it's not a natural number. Y becomes 0, that means 0 is not a natural number. So this condition cannot be taken. And after that, any number you take, you will not be getting exact condition to be satisfied. Okay, so only this pair, these two ordered pair will be the result of your relation. So if we write in a better way, we can write relation is equal to 1 comma 8 and 2 comma 4. This is the final result. Now you have to find what is the domain of this relation. So in that case, the elements will be 1 and 2, 1 comma 2. And if you write the range, it will be 8 and 4 or 4 and 8. Okay, so this is how you have to find domain and range of the given relation. Next question is fifth one. If R be a relation on n, that is natural number, defined by R is equal to x comma x square, where x is a prime number less than 15. You have to find the relation roster form, domain and range. So roster form will always have your elements listed. Okay, here let's write natural numbers always start with 1, then comes 2, 3, 4, 5 like that, and the prime number, it is less than 15. So let's write this number goes on, and x you have to mention as prime number which is less than 15. So let's write the relation should have prime numbers. Okay, so 2, then comes 3, 5, 7, 11, 13, not 15 because it is less than 15. So these are the elements in your relation. Now the relation will be explained by x comma x square. Okay, so that pair should be like this. So 2 and 2 pair will be 2 square, then 3 3 square, 5 pi square, 7 7 square, 11 11 square, 13 13 square. Okay, so these elements will be there in your relation. Let's elaborate and write it. 2 comma 4, 3 comma 9, 5 comma 25, 7 comma 49, 11 comma 121, 13 comma 169. Okay, so this will be there as the final result of your relation. Then comes domain. You have to find out what are the domain. So if you say domain, it will be 2, 3, 5, 7, 11 and 13. Okay, 2, 3, 5, 7, 11 and 13 are the domain. And if you say range, range will be the second part, that is 4, 9, 25, 49, 121 and 169. Okay, second part of your ordered pair. So this is the domain and range, and relation is mentioned. Let's go to the next question, sixth question. Sixth question is, if R is a relation on set of real numbers defined by x comma y, and x square plus y square will give you 0. So we have to write the relation. So that means the relation will be x square plus y square should give you the element as 0. Okay, so do you have anything that gets added on and give you a result as 0? That's not possible, because whenever x square plus y square equal to 0, here if you have do some square of any of the number, let it be -1, whatever it is, you will always get a positive result. So the result will turn to be positive here. If it is 3, okay, then you will have 9. So any number will give you the positive result and it is getting added up. So no chance you have to get a result as 0. So you will not have any of the elements like that. So the relation is an empty relation. That means nothing is there as the element. And for that type of relation, you will have the domain as again null and again range will be null. Okay. 7th question, x plus 1 and y minus 2 will give you the result as 3, 1. That means x plus 1 is 3 and y minus 2 is 1. Find the value of x and y. So that's very simple. X plus 1 is equal to 3. Y minus 2 is equal to 1. Okay. So x is equal to 3, and when this goes to the right hand side, it automatically changes its operation. What is happening? That is 3 minus 1, it becomes, that is 2. So x is equal to 2. Y is equal to, it goes to the other side of the equation and you will be getting 1 plus 2, that is 3. So next question is 8th question, that is A is given as this one. You have to find A into A cross product of A and A cross product of A, or Cartesian product of A by itself. So A is minus 1 comma 1. So what is happening in this case is minus 1 minus 1 minus 1 minus 1 minus 1 1 minus 1 1 minus 1 minus 1 1 1. Next will be 1 minus 1 minus 1 1 minus 1 1 1 1 minus 1 and 1 1 1. So you'll have 8 elements in your result. This is the final result. You have to check all the combinations possible. Since we have 2 elements in each set, 2 into 2 into 2, that is 8 elements we will get in total. Our question is A cross B is equal to this one. It is the ordered pairs are given. You have to find A and B. So from the equation you can say A and B are the elements of your A set, and B will have X and Y is a repetition, again X and Y, same repetition is there. So A and B are the results of set A and B. Okay, next question is 10th question, and this is the final question of this video. If number of elements in A is 6 and number of elements of B set is 3, then you have to find out what will be the cross products A and B. Final result will have how many elements in them. Okay, so this is a formula. Number of elements in B, when you have the cross product of them, just multiply the total number of elements, that is 6 into 3, that is 18. So you will have in the result 18 elements when you find the cross product of A and B. Okay, hope you understood. So to refer to the concept, just go to the previous videos of relations and functions that is available in the playlist. Go and watch them. You will understand how to find if you have the problem with the concept. Hope you understood. Let's see in the next video.